Hello everyone, it's a pleasure meeting you all in my mathematics class. Today I will take up the next, that is, I have already discussed and done problems in binomial distribution. It is a discrete random variable. This discrete random variable, it is a discrete random variable that follows the binomial distribution. Here this Poisson distribution is also a random variable that follows that is discrete, okay, that it takes finite number of values. Here, before doing this problem, let me give a small explanation about what is a Poisson distribution. Now you see that in the difference in binomial distribution, we talk about the probability of success and probability of failure. But probability of failure is nothing but 1 minus probability of success, because two things can only happen. That is, two outcomes can happen in an experiment. In this point, that the number of trials are definite. The number of trials are definite. N in number. N can be a definite number. But in this particular case, Poisson distribution, the number of trials are indefinite. That means infinite number of trials. That means the trials are infinite. The trials are infinite in number, and because of this, what happens is that because of this, we try to we calculate the probability of success as nothing but the average, that is the expectation of the Poisson distribution. We take the expectation of the Poisson distribution as the it is a parameter. It is a parameter with which we work the problem in Poisson distribution. That is, in order to make you understand better, I will before that I try let x follow Poisson distribution. Let us suppose that it is Poisson distribution. Let x follow. X is a random variable. X is a random variable that follows Poisson distribution. Then the probability mass function. The probability mass function is given by P of x is equal to R is equal to e to the power minus lambda, lambda to the power of R, or factorial, or will take the value. Now you see that here we don't talk about the probability of success or failure like that. Instead of that, here we come across a very important parameter lambda, which is nothing but the expectation of the random variable x. That is, we take the where lambda is equal to E of x. Where lambda is equal to E of x, where lambda is equal to, that is expectation of the random variable x, that follows the Poisson distribution. So here the parameter is lambda. So we work out the whole problem. That means if the 1000 trials are taken, if infinite number of trials are taken, then we just find out what is the average success of that, with which we start working on the problem for any questions. We answer any questions in that. So this lambda is the parameter, and this lambda is the parameter which is nothing but the average of the random variable that follows Poisson distribution. And incidentally, note that the variance of the Poisson distribution is also lambda. That is also sigma x square is also lambda. These are the proofs. Say sigma of x square is equal to lambda. So the speciality of Poisson distribution is that the number of trials considered are infinite number, and there is one parameter with which we work, that will be lambda, and that lambda is nothing but the is the average. This is nothing but this is also equal to your NP actually. This is your NP. Actually, this is your this is your averages NP, and so this lambda is nothing but your NP. We work out all the problems using only this parameter lambda. Now, say I will derive this lambda, what is E of x is equal to lambda and sigma of x square is equal to lambda. I will derive that, how that is done, I will explain. Okay. After that we can come to the problem. Solving the problem is not a difficult one, but understanding the subject is very, very important. Okay. Now let me start doing this. See. So here what we have to understand is that, unlike in binomial distribution the number of trials are n in number, but here it is infinite in number, and that the problem is worked out based on a special parameter lambda or a mu, anything that you can call. It is nothing but with the average taken on the Poisson distribution. If E of x, if x is a random variable that follows a Poisson distribution, then E of x is lambda with which we work the problem. Okay. Now, here I will do this. See, to prove, see, we know that if x follows Poisson distribution, with parameter lambda, then if x is follows Poisson distribution with the parameter lambda, then E of x is equal to lambda. So let us now prove this. Now we know that P of x is equal to R is equal to, we know that before that it is e to the power of minus lambda to the power of R divided by R factorial, R is equal to infinity. Now also d of x is equal to 0 to infinity of p of x, or you can write p of x also. Here it is equal to, it is 0 to infinity of x into e to the power of minus lambda to the power of x divided by x factorial. So I will take this is e to the power of minus lambda has nothing to do with the summation. So e to the power of minus lambda, and I will take this, it is 0 to infinity, it is x into lambda to the power of x minus 1. I will take this lambda also outside, divided by, that is equal to e to the power of minus lambda in lambda, it is 1 to infinity of lambda to the power of x minus 1 divided by x minus 1 factorial. You know how we are getting this? This is nothing but this is x and x minus 1 factorial. X and x will go off, giving you x minus 1 factorial. See, this is x. This factorial of x is x into factorial of x minus 1. X and x will go off, leaving you with x minus 1 factorial. And this x will run from 1 to infinity. Now, if you start expanding this, you will get this to be e to the power of minus lambda, and if you put 1, x is equal to 1 means it is 0, 0 factorial is 1, anything raised to the power of 0 is 1, so 1 plus e to the power of e, it is, if you put lambda here, lambda divided by 1 factorial, lambda squared by 2 factorial, it runs like this, lambda to the power of r by r factorial, like this it goes on. So this is nothing but an exponential series. So this is nothing but what? It is lambda into e to the power of minus lambda into e to the power of lambda, that is equal to lambda. So I am able to get e of x is equal to lambda. So I have proved that e of x is equal to lambda. So this e of x has been proved to be lambda. Now let me prove e of x, say sigma of x square. So let us prove now e of x square is equal to, see we know that, before that you must know what is this. We know that the variance of x square is equal to e of x square minus e of x whole square. So this is, so if I must know what is the value of this. This value I know, but this value I have to find. Now e of x square is equal to sigma of 0 to infinity x square e to the power of minus lambda. It is lambda to the power of ax divided by x factor. This we cannot put it in this way. This is nothing but it is 0 to infinity x into x minus 1 into, it is e to the power of minus lambda into lambda to the power of x divided by x factorial. Now you see that I am getting x squared here. By minus x is there. So what should I write here is, here x into e to the power of minus lambda, lambda to the power of x divided by x factorial. So here I am writing this x squared as x into x minus 1 because I am adding minus x squared. I am adding this minus of x squared, x. See, x squared will come here. X into minus x will be, I have to subtract that because I cannot change the value of this, but I can do some manipulation. So you see that I write it as x into x minus 1, but in the place of this a minus x I have added. So I have subtracted. So I will naturally add. Then only that is, it will remain the same. I cannot alter it. I should not alter it without weighing it. I can do some manipulations only. So I have done some manipulation in order to get the answer. So I have done that. So I have subtracted. So I will necessarily add. But this is nothing but what? Your mean of x. This is nothing but your e of x, which is equal to lambda. So this is what? So you see that I will write this again as, here it is x into x minus 1. So this can be written as, say I will write one more step. Here I will write. I will write it here. See. I will write here. So this can be written as e to the power of minus lambda can be taken outside. And I take this lambda square outside. And inside that I will explain how we are getting this. It is x into x minus 1. This can be written as x into x minus 1 into x minus 2 factorial into lambda to the power of x minus 2 plus lambda. You know how I am getting this? So here in this place, this lambda factorial of x can be written as x into x minus 1 into factorial of x minus 2. So that we see that x into x minus 1, x into x minus 1 will go off, and then the value of this, as we know, we have already derived that this is equal to e of x. So what we are getting here is that it is e to the power of minus lambda plus into, it is into lambda square, and here you get this to be what? 2 to infinity. It is lambda to the power of minus 2, it's lambda to the power of x minus 2 divided by x minus 2 factorial plus this lambda. So this is what we get. Now if you start getting the values for 2, if you start getting the value 2, if you give 2, it is 2 minus 2 is 0, this is 0. So you get again the exponential series, that is 1 plus lambda square by factorial 2 plus lambda cube by factorial 3. So I will write, if you want I can write that also. So I will write it here. So what is that we get here? So sigma of, say I will write here e of x square. E of x square will be, this will be e to the power of minus lambda into lambda square into within this bracket we will get 1 plus lambda by factorial 1 plus lambda square by factorial 2 dot 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 up to infinity plus lambda. So this is what you will get. Now if you go for the simplification, say what is, how will you simplify this? So this is nothing but e to the power minus lambda into lambda square into, this is nothing but your e to the power of lambda because this exponential series with e to the power lambda as the power, e to the power of lambda plus lambda. So this will be nothing but what? This e to the power of lambda into e to the power of lambda, this will give you lambda square plus lambda. You call this as your 1. Call this as your 1. We know that your sigma of x square will be equal to e of x square minus e of x whole square. So this is nothing but what? Your lambda square plus lambda minus lambda whole square. So lambda square plus lambda minus lambda square which is equal to lambda. This implies sigma of sigma square of x is equal to lambda and e of x is also equal to lambda. Now you see that this on the, well, this is, so I have proved that the mean of a Poisson distribution is the parameter lambda and also the variance is also equal to the parameter lambda, and that a Poisson distribution as given by this. What is the Poisson? That is the probability mass function of a Poisson distribution. It is P of x is equal to r is equal to e to the power of minus lambda, lambda to the power of r, factorial r is taking the value 1 to infinity. So with this background, now let us start doing the problem one by one. See, of course the calculation part of it, I will just tell you how it should be done. You can work out and verify whether we are getting the same answer. Okay. Now, let me start doing this. So the first one, see. So what is none? See here, the probability of a person reacts to the newly. See, there is a newly manufactured vaccine and it is being tested and it is found that the probability that a person reacts is 0.002 who gets the injection. And the 400 people are treated with a vaccine. Find the probability that none will react to the vaccine. Exactly 1. All these questions we have to answer. Now, before this, what is that we have to find? So this is, see that this we have to, here it is given that your probability of reaction, see, probability of reaction to vaccine is equal to 0.002. And we see that the trials taken the trials are very huge. It is not a definite number 10 or 15 or 20 like that. It is 400. In fact, it can be more also. But here it is given to be 400. So if you see that the number of trials is equal to 400, therefore E of x is equal to, it is n into p, that is equal to 400 into 0.002, that is equal to 8. So your lambda is equal to 8. So I am able to determine the parameter of the Poisson distribution. Lambda is equal to 8 is the what? The parameter of the Poisson distribution. Now any problem can, once this is found, any problem can be worked out. Now, having found this, let us start doing the problem one by one. See? So the difference, you must know the main difference, binomial distributions, P and P will be there, so the Q will be 1 minus P. But in the case of Poisson distribution, you must have what is called your lambda. Lambda is nothing but the average of the Poisson distribution, of the random variable x that follows the Poisson distribution. Okay. Your A. So lambda is found. Now we know that, I'll write here, we know that P of x is equal to r is equal to e to the power of minus lambda, lambda to the power of r, factorial r is there taking the value up to infinity. Okay. Now this is the probability mass function of this, and x follows the Poisson distribution, and x is the number of persons who react to the vaccine. That is, x follows the Poisson distribution, and x is the number of x refers to the number of persons who react to the vaccine. Okay. So with this, so we should know what is a random variable x. What really is that random variable x? And now, having known that x, we can just work out any problem. And also we know that it follows the what? The Poisson distribution. Okay. Now let us start A. What is that? Here none react. That means what? None react means probability of the number of persons who act. That means no one reacts. That means what? R is equal to 0. That is, no one reacts to that vaccine. So P of x is equal, wherever R comes, you put it as 0. So it is e to the power of minus lambda divided by 0 factorial into lambda to the power of 0. That is e to the power of minus. It is e to the power of minus lambda divided by this is 1. So everything this is e to the power of minus lambda. That is equal to e to the power of minus 8. Now e value we know, you can go, you use any calculator, scientific calculator and anything, and you will find that the following are the answers to the problem. See, this is what you will get. See, 0.00. So this is the answer that you get for what? That means the probability that no one reacts to the new vaccine. So this is it. Now what is your x is exactly equal to 1? Exactly equal to 1 means here put n is 1. So this is equal to e to the power of minus lambda into a to the power of 1 divided by 1 factorial. Because your r is equal to, see, 1. Lambda is equal to 8. Lambda is equal to 8. So this is what you get. So this is nothing but what? 8 into 0. That is e to the power minus lambda. When you go for the multiplication of that, what that you will find is 0. You will find that this one. 0.002 to 686. Then, what is the probability that exactly 2 gates? See, the third question is, this is your B. Your C is probability that exactly 2 gates. So, this is nothing but what? E to the power of minus lambda into 8 squared by factorial 2. So, you will get this to be, so this is nothing but your, this is 64, 32 into e to the power minus lambda. So, you will get the value to be 0.010, something like that. Now, then what is the next question? I will do this. See, exactly 1 will get, and at least 3 will get. That will come to that afterwards. Then E, let me write here E. See, at most 2 will get. What is the meaning of this E? P of at most means less than or equal to. That means the number of persons who react may be 0 or 1 or 2. Definitely not more than 2. At most 2. So this is nothing but what? So this is equal to P of x is equal to 0 plus P of x is equal to 1 plus P of x is equal to 2. So this is nothing but, this is P1, see, this is P1, this is P2, this is P3. You sum up everything. What that you will get here is, you will get this to be your 0.0 0.0137617. So this is one. So this is answer for the eighth question. I have not done the eighth question. I have done the eighth question, where the eighth question asks you at most 2 will react. At most 2 means what? 0 may be there, 0 may react, or 1 may react, and 2 may react, and not more than that. That is why I have written P of x is less than or equal to 2. But that is x is equal to 0, or x is equal to 1, or x is equal to 2. So what is it equal to? So P of x is less than or equal to 2 is equal to 0.0137617. That is the probability that at most 2 react to the vaccine is 0.0137617. Now let me do the D question. What is the question D now? Question number D. See, question number D is, your question number D is at least 3 will react. That means probability. See, x is the number of, x is the random variable that tells you about the number of people who will react to the vaccine. He says it is given that at least 3. That means what? X is greater than or equal to 3. See, it can be equal to 3. It can be equal to 3. Or that is, number of persons who react should be 3 or more. That is, x is greater than or equal to 3. Now, what is the probability of this? What is the probability of this? This is nothing but what? This is nothing but your P of x is equal to 3 plus P of x is equal to 4 and dot dot dot. Now, the 400 people are this thing. So, you have to ultimately go for what? What about 400 people or this thing? So, it can be 3 people may react, or 4 people may react, or like that it goes on. So, this is nothing but what? So, it is 3, 4, like that it goes on. See? 0, it is up to 400. 1, 2, 3, see. So, 3 or more. But the whole probability is 1. So, 1 minus P of x less than, see, less than or equal to 2. That means 3 and above. 3 and above means it is the whole probability is 1. 1 minus less than 3. Less than 3 can be what? Because it's a discrete random variable. It can be 1, 2, 3 like that. If it is not 3 means it has to be only 2. Okay? So you see that the number of, that is 1 minus P of x less than or equal to 2. That means here I can write instead of calculating. See, calculation of this will be very tedious. So what we do is, it is 1 minus P of x less than or equal to 2. So this is 1 minus P naught plus P1 plus P2. That is 1 minus, see, P naught plus P1 plus P2. This is nothing but your P naught. So this is, which implies P naught plus P1 plus P2 is equal to 0.0137617. So you see that we have got this. So subtract this 0.0137617. So if you do the subtraction and everything, you will find that it is 0.9932344. So this is what it is. So that means the number of persons who are not, that is the number of persons who react to the vaccination is more than 3 or more. At least 3 means 3 or more is 0.9932344. So this is how we do problems in Poisson distribution, and we can find out defectiveness, non-defectiveness, and the accidents happening. All these things can be found using Poisson distributions. And in Poisson distribution, the main thing that you must know is it is concerning infinite number of trials, and therefore we cannot use the binomial distribution. And here we use the parameter lambda, which is determining the problem, any problem, which gives the answer for any problem, and that the parameter lambda is nothing but the average of the random variable that follows the Poisson distribution. And the Poisson distribution, as I told you, it is given by e to the power minus lambda into lambda to the power 1 divided by r factorial, where lambda is nothing but the parameter. Okay, so this is all about this problem, and I will take more difficult problems in the coming days. Thank you.